Okay, here M1 is greater than M3, so M1 will accelerate down, M2 will accelerate to the left, and M3 will accelerate up. Looking at the scenario, that means that we have the Earth pulling down on M1 and the string pulling up. And the string has to be less than M1G. For the middle object, and by the way, this is the left string because there are two different strings. For object number 2, we have the left string pulling to the left and the right string pulling to the right. And the right string has to be smaller than the left string because it is accelerating to the left. 2, visually speaking, is the most massive. So you have the normal force in mg being quite large there. For object number 3, we have the string pulling up, so M3G is going to be the smallest here. M3G is going to be the smallest. The string pulling up has to be the same size as the right string. So this is one going up. So that's why I erased the other one. M3G has to be smaller than the string pulling to the right because the acceleration is up. So just be careful with the arrows in your force diagram. Now we're going to set up Newton's second law for each one and then determine the acceleration for the entire system. So in force diagram 1, down is positive, up is negative. In force diagram 2, left is positive, right is negative. And in force diagram 3, up is positive, down is negative. And that's because, again, using the direction of the acceleration, we will call that the positive direction. So here we have M1G minus the force of the string on the left-hand side over M1 is equal to the acceleration. That's for object 1. For object 2, we have the force of the left string minus the force exerted by the right string over M2.